Lesson 6.3 is what we have in store for today, multivariable linear systems. So this time we're going to have a little bit bigger systems than we worked with the first two sections of chapter 6 here. So we'll have up to 3 variables. One example that we're going to be looking at today is called row echelon form. Okay, that might be a new term or new phrase for you guys. So take a look at what I'm talking about on page 446. The first example towards the top of the page there gives you an example of what this row echelon is going to look like. Notice that the first line has 3 variables in it, but the second equation in the system only has 2, and then the last one has just 1. So see how it kind of decreases or resembles a stair step. Okay, so with this one, I kind of like these actually because in this sort of a system, the last one or the third one of the system is already solved. Z is equal to 3. So then we can use something that's called back solving, or taking it and putting it back into the one above it, or at least that's how I interpret it, back substitution, to find out the next one. So seeing as we already have this, the line right above it has just a z as a variable and one more, the y. So if I were going to continue solving this one, it would make perfect sense to plug it in there, because then I can come up with a number for y. So let's do that. So multiplying, and then subtract 9. And I have a second number for my system. Now I have 2. I can use my top equation to find the last one. So plugging the 2 that I have into that top line, I don't have x yet, but now we have y. We already had z, and we can solve. So simplifying. Minus a minus 3. 5 times 3 is 15. Combining like terms, we get an 18 here. Now we can get rid of the 18. 2x ends up equaling 4. Last is to divide away the 2, and x equals 2. So we have numbers. We have numerical values for each of our variables. The answer to this solution then is stated this way. Our x value, y value, and z value, written as such. Checkpoint number 2 in the problem, or in the book, just gives us another look at systems that we can end up solving. This one is not even overly difficult in my opinion. It's an easy one you could use substitution on if you wish. There's a couple of isolated single positive variables to work with. I still am kind of one of those people that likes elimination better. So I'm going to choose to eliminate my x values. I'm going to multiply a negative 2 times this bottom row. So leave the top one alone. Multiplying negative 2 through the other one, I get a negative 2x plus 2 times, whoops, not that. Negative 2 times 2y be negative 4y, sorry. And negative 2 times 3 is negative 6. Combining, negative 3y equals negative 3. Divide by negative 3, and y is equal to 1. Now I can substitute in. Either line, doesn't matter. I'm just going to go with the top one. Plug my 1 in for my y, and solve. So the solution to it, 1, 1. All right, checkpoint number 3 on page 448. Now we're getting into a little bit bigger systems yet. Notice that all 3 equations of our system have 3 variables in them. So take a while to decide where you want to attack it. And just because I go at this one in the way that I do doesn't mean that there aren't alternate ways to solve it as well. As I'm looking through these ones, I like elimination better, so of course I'm going to be looking for things that are already opposites of each other. On this one, lovely enough, these two bottom equations have opposites for the y values and opposites for the z values already. So if I combine these two lines, I'm going to eliminate two variables in one shot. So combining, I get 2x and 3x make 5x. 3 plus 2 is 5. So I'm going to be able to find out my numerical value for x right off the bat. Okay, so I have one number found. Now I can go ahead and plug that in um, for another equation. I can eliminate some x's so that therefore I would have just, y's and z's in there. Okay, so let's see what that gives us. I'm going to look at the top two, and I'm going to go ahead and combine there because I can get rid of the y's, and that way I can use the x that I just found to get rid of the x. All right, so combining my top two lines, x and 2x are 3x. My y's, of course, are going to eliminate each other. Z plus z will give me 2z, and then 6 plus 3 will give me 9. Using what I already know, I'm going to insert that 1, start simplifying, get rid of my 3, and get rid of the 2 by dividing both sides. So now I have a second numerical value for z. I can use any of the three lines now, plug in my x, plug in my z to be able to calculate my y. I'm just going to use the top one. My x value is 1. I don't have y yet. The z value we just found was 3 and 6. So simplifying, we get y plus 4 equals 6. Subtract 4, and we have 2. So stating our solution, x value of 1, y of 2, z of 3. So more steps, yes, but still using those same concepts. Substitution method still works just fine. Again, elimination tends to be how I go about more of them. All right, now it is possible that there might not be a solution to the system. We've talked about that already. The way to tell this is if when you're working with it and trying to eliminate variables, you end up with an untrue statement, something to the effect of 0 equals 3, maybe it ends up saying 5 equals 7, but something that's absolutely untrue. If you get to that point, you know that you don't have any solutions. I'd like you guys to look with me at example number 4. If you turn in your books to page 449, you're going to see one of these that's been done for you. Okay, notice through the working of the solution, they end up with a statement that says 0 is equal to negative 2 at the bottom there. When you get to that point, you can stop because there aren't solutions for the system. You've come up with an untrue pairing, and you can just quit. Now, it's also possible, though, to have a system with an infinite number of solutions. If you come to a step in the solution process that gives you a statement that's true, something like 0 equals 0 or 5 equals 5, you have come across something that's like this. All right, so there's a little bit extra legwork to one that comes up like this because we still need to give a solution. And to say that there's an infinite amount of solutions is not enough. Okay, so checkpoint number 5 is going to give us one of these cases. Example number 5 in your book does as well. This you might have to watch and rewatch a couple of times to catch on to this. There's a lot of steps here. Okay, so we go about this. We don't know what's going to be the outcome, so we begin to solve like we always would. So I'm going to focus on my top two equations first. I'm going to eliminate my x's. Okay, so on the top one, I'm going to multiply a negative 2 through my top line so that I create opposite x's and I can eliminate that variable. So my new top equation will be this. My second line, I'm just going to slide it over. I'm going to combine them. In combining them, I'm going to get negative y plus 15z equals 13. Okay, I'm just going to put a star next to that one because I'm going to come back to that and want to use it again here in a little bit. I want to create another equation that has just y and z in it. So I'm going to focus on these two, and I'm going to eliminate the x again. So multiplying the top one by 3 and the bottom one by a negative 2 is going to get me there. Okay, I'm going to change colors here to do this next work. So my new second line, if I multiply a 3 through that top line, or that second one, 3 times 2x, 3 times 3y, 3 times z, and 3 times 5. My new third line, if I multiply through that thing with a negative 2, negative 6x minus 14y plus 72z is equal to 50. Combining them, the x's eliminate. 9y minus 14y is negative 5y. 3 plus 72 is 75z. 15 plus 50 is 65. There's an equation that has a y and a z again. Okay. Now, I'm going to go ahead and take these two new equations that I came up with, and I'm going to use the elimination method on them. So if I take the green one up here, and I multiply that one by a negative 5, I'm going to be able to eliminate my y's. Okay, so negative 5 times negative y is positive 5y. Negative 5 times 15 is negative 75z. And negative 5 times 13 is negative 65. Well, what's going to happen when we combine these? Everything's going to drop away. We're going to get the statement 0 equals 0. So I know I have an infinite number of solutions. All of my variables just dropped away and I have a true statement. What do we do then? Okay, well, we need to now, can't just stop there and say an infinite number of solutions. We need to come up with expressions that represent x, y, and z values that will work. Take a look at the equations that you have and that you've been working with. Can you solve them for a single variable? Okay, so I'm going to look at this green one here. Okay, this is the only one I have so far where I'm down to one, like a singular variable that I could easily solve for. So you guys see how we could rearrange that line so we have a y equals something? So I'm going to bring it over here, and then we're going to mess with that one. Okay, so I could move away the 15z to the right-hand side, and then divide through with a negative 1. Okay, so I don't have a numerical value for y, but I do have an expression for y. Okay, so this right here we want to hang on to. Okay, now I'm going to use that so that I can come up with another expression that I can solve for x with. If I plug that 15z minus 13 into one of my other lines, I'm going to get something that has just x and z in it. Notice the top equation here. Do you see how that one has a plain x sitting there? If I plug that value into that one, okay, and you can put it into the rest and do more legwork to get x alone, but if I put it into that one, the x is already by itself. So I'm picking that one. X 2 times my y expression that has z in it. Now I don't have a y. And I need to simplify. 30z minus 26 My two z terms can go together. 30 and negative 7 make a positive 23z. Then I can move my 26 to the other side. Adding 26 to both sides gives me a 22. And now I can move the 23z by subtracting 23z from both sides. So do you see how I just came up with an x equals expression? Okay. The last thing is, in this is the part that, I don't know, I guess maybe it's going to be the harder part for you guys to get your heads around. If we were to take any number now and choose it for z, we'd be able to put that in these two expressions and solve a number for x and for y. So at this point, we're just going to say, okay, we're just going to pick a number for z. Okay, the book says to let it be the constant a. It could be a 1. You could let z equal 1, plug it in, find the x and the y that go with that if z is 1. You could pick a 2, plug that in, find the x and the y that would go along with a z value of 2. All right, so again, there are an infinite number of solutions that we could find. We have expressions now that will relate the number we pick to plug in for z with the x and y that would go along with it. All right, so this is what we're going for. Listing our answer now. Our x expression is negative 23z plus 22. So we don't have a number for x. We have an expression for x. For y, we found 15z minus 13. And for z, oh, these are a's. No, that'll be all right. No, I am going to change it. Z is equal to a. Sorry. Negative 23a. I think you guys can see what I'm doing here. I don't want to use the z. The y is going to be 15a minus 13. And then, of course, z, the z value is just going to be whatever number we pick. Okay? So if we chose to do 1 for z, okay, plug a into y. We'd have 15 times 1 minus 12, we'd get a 2. Plug 1 into the x expression. You'd have negative 23 times 1, and then add 22 would get a negative 1. This would be one possible triple that would solve this system. I could change my z value. I could change a to a different number and run it through and come up with another triple. There's an infinite number of these triples that we could find. All right, we'll work through another one of them here in a sec. Checkpoint number 6. Solve a system that has fewer equations than variables. Okay, usually when you have a 3-variable system, you're going to get 3 equations. This one doesn't have that. Notice that the top one has a y in it, but the second one does not. So what do we do then? All right, you really don't go about it any other or any differently than the others. I'm still going to use elimination to try to eliminate one of my variables. I'm going to go after the x. I'm going to eliminate that one first. So I'm going to multiply the top line by a negative 4. So multiply negative 4 times x, negative 4 times 4z, and negative 4 times 3. And then sliding my second equation over. Oops. I forgot to write the y one down. Negative 4 times x, negative 4 times negative y, and negative 4 times 4z. Sorry. And negative 12. Now I'll slide the other one over. Second equation was this. Combine. So my x's are going to eliminate. And we end up with this new equation. Okay, now, when we only have one y variable, okay, we could use a substitution thing to sub that y out. And I'm going to use that equation that we just came right now to do that, because I can solve this new one down for y. All right, so that's what I'm going to do next. Move the 17z, and then get rid of the 4. So you're going to have 17 over 4z. That doesn't divide evenly, so just leave it as a fraction. And then negative 12 divided by 4 is negative 3. Okay, plug that into that first line. Okay, so x, and then minus the new y value. We had 17 fourths z minus 3. And then the rest of that first equation stays. And simplify. Okay, combine the z's. Now 17 fourths needs to go with 4, which is the same as 16 fourths, correct? So leave the x alone. There aren't any other x terms. Negative 17 fourths, positive 16 fourths, we're going to get negative 1/4 z. And then I can get rid of my 3. So x minus 1/4 z equals 0. Okay? Now, this new equation, this one and this one have just x's and z's in them. So I'm going to use my elimination method, and I'm going to get rid of one of them. So I'm going to multiply this one. I'm going to get rid of my x's again. I'm going to multiply through here by a negative 4. Okay? So negative 4 times this line, negative 4x plus z equals 0. Negative 4 times negative 1/4 is 1, so I get that 1z. I'm just going to rewrite my other one underneath it. So from up above, my second equation in this system was a 4x minus z equals 0. And notice we're going to get another one of these deals. We get 0 equals 0 again. So again, we have an infinite number of solutions. Okay, so now we're in that place again where we have to come up with expressions for answers rather than numbers for answers, because there's so many of them. Here we go. Back here. Do you see that we already have an expression for y? Okay. Let's use this one. Which one do I want to use? Let's use this one. Do you see how we already have a singular x in that one? If we slide our z to the other side, we end up with x is equal to positive 1/4 z. Okay, so here's an expression that has just an x equal to it. And then again, we're going to we're just going to pick the number for the z spot, and we'll use these expressions to come up with our x's and y's. Solution for this one then. Z is equal to a. So the expression that's going to give me my x value will be 1/4 times z, or 1/4 times a. For my y one, I'm going to get 17 fourths times a minus 3. And then for my z value, that is the a itself that we picked to plug through. All right. This is one of it's called the position equation. We worked with this equation actually earlier on in, I think it was probably the chapter where we worked with quadratics so much. It is a quadratic function. So it's coming back to us right now, and we're going to use systems to help us solve something like this. We're going to use this position equation to find values for velocity and height. That's v and s in this formula. When s is 104 and time is 1, s is 76 when time is 2, and s is 16 at time is 3. So do you see how they're giving you 3 pairings of information? Okay, each of these pairings of information will plug into that position equation right here and make an equation for us to work with. Okay, so let's go ahead and find those, plugging them in one at a time. We're going to have to do them one at a time. We're going to end up with 3 equations here. one for each of our situations. So if S is 104, put that in the S spot. 1/2 times, we don't have a value for A. Time in this first one is a 1. And then we have, I'm going to leave the sub knots out and just put V times 1 plus S. Okay, I just feel it's not quite as clunky to look at if we don't put this whole thing in there. I'm just going to call it V. Whoops, 104. So I'm going to start simplifying here. We have 1/2 times 1. And then V times 1 is V plus S. So we have a 3-variable system. Okay? Do the next one. So 76 is my new height. And that's equal to 1/2 times A at 2 squared. V times 2. And then plus S. So let's simplify this one. Now 2 squared is 4. So 4 times 1/2 is 2. 2 times V and S. There's another equation. Let's do the third situation. Height of 16. We have 1/2 A times our time. This time is 3. V times 3 and S. Simplify. We're going to have 9 times 1/2 or 9/2. And there's our third equation. Okay, so it's a 3-variable system. All right, so if we're going to come up with values for this, we're going to implement our methods. We're going to use elimination or substitution to come up with values for A, V, and S. All right, let's start working. So what I did was I eliminated my x's. Okay, so I used my first two equations. I have, or my x's, my a's, I guess is my first variable this time. I have 1/2 a in the first one, and I have a positive 2a in the second one. So I am going to multiply the first equation by a -4. Okay, so -4 times this one is going to give me -416, -2a, minus 4v, minus 4s. Now I'm going to write equation number 2 over underneath here so I can combine them. So I'm just bringing this one over right now. 76 was equal to 2a plus 2v plus s, and combine. So I get -340. The a's eliminate. -2v minus 3s. So just sit on that one for a second. I've got an equation now that has just two variables. I'm going to be coming back to this. All right, I want to do that again. I want to eliminate a between another pair of lines. So I'm going to use the first one again along with the third one. Okay, so I'm going to this time, instead of putting a -4 through this one, I'm going to multiply by a -9. Because then that will create a -9/2 a, which will cancel out my other side. So multiplying my -9 through my first equation, I'm going to have -936 equals -9/2 a minus 9v minus 9s. Now I'm going to rewrite my blue one, my third line underneath here. And combine. So -920. The a's eliminate. -6v minus 6s. 8s. 8s. Okay, so now these two, they both have just variables of v and s in them. So I can eliminate one of my variables. So I'm going to eliminate v. I'm going to run a -3 through this equation to make +6v here, and that way I can cancel out the -6v next door. All right, so multiplying through this one by negative 3. Negative 3 times negative 340 is positive 1020. Then negative 2v times negative 3 is 6v. And negative 3 times negative 3s is positive 9s. Combining, I get 100. The v's eliminate, and negative 8 and 9 make 1. So nicely enough, we just found s. Now I can plug that one into either of those two green lines that we were working with, either here or here, to find v. So just because I'm running out of room over there, I'm going to go into this one. Negative 340 will equal negative 2v minus 3 times 100. Add 300 to both sides. Divide by negative 2. And 20 equals v. I have one last variable to solve for. So using any of your initial or earlier systems, you can plug those two values in. I'm going to use this one because I just feel the numbers are simpler. All right, you can choose whichever one you want. So 76, we don't have a yet. 2 times v, which was 20, plus s, which was 100. So simplifying, we're going to get 140 over here. Subtracting 140 from both sides, we're going to get negative 64 equals 2a. Dividing by 2, we get negative 32 for a. So here's the three values that we were coming up with. Okay. All right, this last thing that we're going to take a look at today, folks, we're going to find a quadratic equation. Okay, we know that those are y equals ax squared plus bx plus c, whose graph is going to pass through the points 0, 0, 3, negative 3, and 6, 0. So it's working backwards. It's giving us the solution to our system, and we're coming up with the quadratic that it might come from. Okay, let's go ahead and use these numbers. Each one of these is an individual xy. Okay, and if we're trying to come up with something that has x's and y's in it, we don't have a, b, and c. We have three variables that we don't know. Three variables creates a system for us. So we're going to come up with equations, one for each of these points. So plugging 0, 0 in first. 0 for y, a times 0 squared, plus b times 0, x's were both zeros on that first point, plus c. Okay, let's make our second equation. Using this one now, the y value is negative 3. I'm going to do a divider here. A times, my x value was a 3, so 3 squared. B times that 3, plus c. So simplifying, well, we'll do that in a second. Let's write our third equation up first. 6, 0 is our final point, so the y value is 0. X value is 6, so we want 6 squared next to our a. And then b times that 6 and plus c. All right, so let's do some simplifying. 0 equals, now a times 0 plus b times 0, those are gone. So nicely enough, this first one simplifies and actually gives us a numerical value for one of our variables. Let's take a look at the second line. This is going to be 9a, 3b, plus c. The third one over here, simplifying, we're going to have 36a and 6b and c. Okay, so that little bit of simplifying that we already got from our first equation here is going to come in handy because now we can put zeros in for c's and the c's are gone. So we're really looking at this and this. Okay, with those c equals zeros out of there, we have a two-variable system. So again, pick whatever one you want to eliminate, do a substitution if you wish. I'm going to eliminate my a's, so I'm going to multiply by -4 on my top line. -4 times 3 is 12. -4 times 9a is -36a. -4 times 3b is -12b. Rewrite the second line. Combine. 12 and 0 is still 12. My a's eliminate each other. -12 and +6 make -6b, and I can divide by -6. Now I have b. I can use b and c then, and I can come up with, or I can just use the b and plug it back maybe into this one to find a. So 0 equals 36a plus 6 times -2. Move the 12 to the other side. And divide off the 36. Do not punch that division into a calculator. 12 over 36 simply reduces to 1/3. All right, so A, B, and C are the numbers that are in your quadratic. So let's make the quadratic equation from all of three of those numbers. So 1/3 x squared plus, actually minus, because it was a -2. You could do plus a negative if you wanted to. Minus 2x, and then plus 0, which is up to you whether or not you write. There's my quadratic. Okay. So for your assignment, page 454 through 457. I told you guys I was going to assign you some problems to do. I may do that in class tomorrow. I've decided against it for right now. I do want you to do a bunch of practice. I want you to focus on a few of the story problems. But let's see where you guys are at when you show up for class tomorrow.